Hello students, myself Varekar A.N. from SGM College, Karad. We already started a topic, vectors. In last lecture, we studied how to represent a vectors and how to find the magnitude of a vectors. Now, this is lecture second. In this lecture, first point is algebra of vectors. That is scalar multiplication. How we multiply the vector by a scalar. Let A bar be any vector and k be a scalar. Suppose A bar be any vector and k be a scalar, then we have to multiply this scalar k to A bar. We will get k A bar. Then if we multiply or we find out, if we have to find out its magnitude, then its magnitude is magnitude of k A bar is equal to magnitude of k and magnitude of A bar. If magnitude of k here, k is greater than 0, then this vector is in same direction. If this value of k is less than 0, then this vector is in opposite direction. So this is very important. That is magnitude of k A bar is equal to magnitude of k magnitude of A bar. So start with some examples. This is very simple point. Just multiply by this scalar to that vector. If A bar is equal to 4i cap plus j cap minus 3k cap, then find 5a bar. 5 is a scalar. If we multiply 5 to the A bar, then what we will get? 5a bar is equal to 5 into that vector. So multiply each and every term of that vector. So 5 into 4 is 20 I cap. 5 into j cap, that is plus 5 j cap. 5 into minus 3, which is equal to minus 15 k cap. This is very simple. Next, another example. If v bar is equal to 2 I cap minus j cap minus 3k cap, then find minus 5 by 3 v bar. If we have to multiply by minus 5 by 3, then minus 5 by 3 v bar is equal to what? Minus 5 upon 3 into that vector. Just multiply to that. That is minus 5 into 2, that is minus 10 by 3 I cap. Then this minus minus get plus, minus 5 j cap upon 3, minus minus again get plus, 3 get cancel, so it is 5 k cap. Then determine the value of alpha that satisfies alpha b bar is equal to 5, where b bar is equal to 2 I cap minus 4 j cap plus 3 k cap. This is very important example, which is of 2 mass example. It has a 2 mass. Determine, we have to determine the value of a alpha. We have to find the value of that scalar, that is alpha. So what is the solution? Here magnitude of alpha b bar is equal to 5, which is given. But we have magnitude of alpha b bar. How we find the magnitude? Square root of its coefficient squares and add it. Okay. If we multiply b bar by alpha, then if we multiply this b bar by alpha, then it will become 2 alpha I cap minus 4 alpha j cap plus 3 alpha k cap. So its first term is 2 alpha its square plus minus 4 alpha bracket square plus 3 alpha bracket square and its square root. This is the magnitude of alpha b bar. So its value is 5. Its square is, if we square alpha square, alpha square, alpha square, get outside the square root. We don't have its sign if it is positive or negative. So we write here magnitude of alpha. I don't know, we don't know it is positive or negative. So it is magnitude of alpha. Root of 2 square is 4, minus 4 square is 16 and 3 square is 9. If we add this, it will become root of 29. So magnitude of alpha, which is equal to root 29, this is multiply here. So here divide by 5. So alpha is equal to here plus or minus. We don't have its sign. So we write here plus or minus 5 upon root of 29. This is a very important example. Then Next point is note about this scalar multiplication. What is first note? If k is equal to 0, if that scalar is 0, then what is about k a bar? It is also a 0 vector. Then a bar is a vector. If we multiply that vector by a scalar, that is k, then these two vectors are collinear or parallel vectors. This is very, very, very important property. If we multiply this vector by a scalar, then these two vectors are collinear vectors or parallel vectors. That means if a bar and b bar are collinear vectors, if a bar and b bar are collinear vectors or parallel, then a bar is equal to m into b bar, where m is any positive scalar. M is not equal to 0, that means m is any positive scalar. This is also important property. What is that? A bar is equal to mb bar. If one vector is equal to scalar into another vector, then these two vectors are collinear or parallel vectors. Remember this is a very important property. This fourth property is also important. This is we used this property is in example. Let a cap, what is a cap? This is a unit vector. This is unit vector along the vector a bar. What is b cap? B cap is the unit vector along the b bar. What is c cap? C cap is the unit vector along the c bar. Here a cap is the unit vector along the a bar. Then if we have to find a cap, then what is a cap? A cap is equal to that vector divided by its magnitude. That is, a cap is equal to a bar upon its magnitude. So remember this point. A cap is equal to what? That vector divided by its magnitude. You have to remember these two, third and fourth note. That is, if we a bar, if one vector is a scalar multiple of other, then it is collinear or parallel. And next is a cap is equal to that vector divided by its magnitude. Then next is a vector of length k in the same direction as a bar is k a cap is equal to. Here what is that? If we multiply a cap by any scalar, then we multiply right hand also. Here look at here, a cap is equal to a bar upon magnitude of a bar. If we multiply by k here, then we multiply by here k. So this is very simple. Fifth note. Remember third and fourth note. Then next point is addition of two vectors. How we add two vectors? If a bar and b bar are any two vectors, then their addition is denoted by a bar plus b bar. Addition by plus sign, a bar plus b bar. There are two laws of addition of vectors. First law is parallelogram law that you studied in 11th standard in physics subject, parallelogram law. What is that? If a bar is one vector and b bar is the another vector, if there is a two vectors, a bar and b bar, consider in this diagram, if ab bar is equal to a bar and ad bar is equal to b bar. These two are adjacent sides of a parallelogram. If these two are adjacent sides of the parallelogram, then the diagonal, then what is its diagonal? Its diagonal becomes a bar plus b bar. It is equal to what? This a bar plus b bar. This is called as parallelogram law. If a bar and b bar are adjacent sides of the parallelogram, then the diagonal is a bar plus b bar. Then next law is triangle law of addition. This is also very simple. Suppose there is a triangle ABC. If there is a triangle ABC, here AB bar is equal to A bar and BC bar is equal to B bar. we have to find AC bar. So we extend this AD bar is equal to BC bar and AB bar is equal to DC bar. That means we form a parallelogram. Then by a parallelogram law, if A bar and B bar are two adjacent sides, then what is its diagonal? Its diagonal is the addition of these two vectors, that is A bar plus B bar. So here, if AB bar is equal to A bar and BC bar is equal to B bar, then AC bar is equal to what? A bar plus B bar. Here we use law of parallelogram. So this is a triangle law of addition. Then some examples. First example, if A bar is equal to I cap plus J cap minus K cap and B bar is equal to 3I cap minus J cap plus 5K cap, then find A bar plus 2B bar. We have to find A bar plus 2B bar. We will write here what is A bar, what is B bar. We have to find A bar plus B bar. A bar is given, we write here, plus 2 into B bar, we write here. Firstly, we multiply this B bar by 2. We will get 6I cap minus 2J cap minus 10K cap. If we make addition or subtraction by their signs, according to their signs, I cap plus 6I cap, which is 7I cap, J cap minus 2J cap, which is minus J cap, and minus K cap minus 10K cap, which is equal to minus 11K cap. This is very simple example. Then next example, if U bar is equal to 3I cap plus 2J cap plus K cap and V bar is equal to I cap minus J cap minus K cap, then find U bar plus 2 upon 3 V bar. We write U bar here and V bar here. Given quantities, firstly we write here. We have to find U bar plus 2 by 3 V bar, which is equal to, what is U bar? U bar is 3I cap plus 2J cap plus K cap plus, this is 2 by 3. Then V bar, what is V bar? I cap minus J cap minus K cap. First we multiply this bracket by 2 by 3. What we will get? This is as it is, 2 by 3 I cap minus 2 by 3 J cap minus 2 by 3 K cap. We will make the addition or subtraction according to their signs. What we will get? Here 11 by 3 I cap plus 4 by 3 J cap plus 1 by 3 K cap. This is our second example. Then next is subtraction of two vectors. If there are two vectors, A bar and B bar, then A bar minus B bar is equal to what? It is equal to A bar plus minus of B bar. Subtraction means this is nothing but a negative of a vector. What is minus of B bar? It is a negative of a vector of B bar. In types of a vector, we studied that. What is negative of a vector? What is negative of a vector? It has the same magnitude but different directions. So what is minus of B bar? It is negative vector of a B bar. So look at this diagram. If AB bar is equal to A bar, BC bar is equal to B bar, then its opposite vector, this is BD bar, its opposite vector, equal magnitude but different direction, which is minus of B bar. Then by triangle law, if this is A bar, this is B bar, then what is AC bar? It is A bar plus B bar by triangle law. Now in this, if this is A bar and this is minus of B bar, then by triangle law, this is A bar plus minus of B bar. That means A bar minus B bar. That means A bar minus B bar. This is subtraction of two vectors. So some examples on that. First is, if A bar is equal to I cap minus 2J cap minus K cap and B bar is equal to minus I cap minus 3J cap minus 5K cap, then we have to find 3A bar minus B bar. So A bar is here, B bar is here. We have to find 3A bar minus B bar. So 3 into bracket A bar minus B bar. Multiply by 3 into bracket, that is 3 I cap minus 6 J cap minus 3K cap, plus this minus minus get plus, minus minus get plus, minus minus get plus. Add or subtract this corresponding 3I cap plus I cap, 4I cap. Minus 6J cap plus 3J cap, that means minus 3J cap. Minus 3K cap plus 5K cap, it is 2K cap. This is our first example. Then second example, if U bar is equal to I cap plus 2J cap plus K cap and V bar is equal to I cap plus J cap minus K cap, then find U bar minus 4 by 3 V bar. Here we write here U bar and V bar. Then U bar minus 4 by 3 V bar is equal to U bar as it is minus 4 by 3 V bar as it is, which is equal to U bar kept as it is minus 4 by 3. If we multiply minus 4 by 3 to this bracket, we will get minus 4 by 3 I cap minus 4 by 3 J cap plus 4 by 3 K cap. So what we will get? It is minus 1 by 3 I cap plus 2 by 3 J cap plus 7 by 3 K cap. Then this is the subtraction of two vectors. Then next notice, if vectors A bar and B bar are acting simultaneously, these two notes, first and second note is very important. If two vectors A bar and B bar acting simultaneously, then we use parallelogram law of addition. And if these A bar and B bar are acting one after another, then we use triangle law of addition. This is the hint or trick to how to which law is applied to that example. If there is a bar and B bar are simultaneous, then we use parallelogram law. If A bar and B bar acting one after another, then we use triangle law. Then adding vector to its opposite vector, we will give 0. Suppose there is a P bar is any vector. Here we give an example, PQ bar plus QP bar, which is equal to what? PP bar. That means it is 0 vector, minus of vector, because it is opposite of vector. PQ bar is equal to minus of QP bar. So we will get here 0 vector. So this is also important. Then we use this, that is in triangle ABC. Suppose AC bar is equal to minus of CA bar. Then what is about that? AB bar plus BC bar plus CA bar. AB bar plus BC bar, it will become AC bar. So AC bar plus CA bar. So what is CA bar? CA bar, it is minus of CA bar. So AC bar plus minus of AC bar, it will use 0. That is AA bar, which is equal to 0. So this is third and fourth note. These two are similar. Then next is, this is a law of extended law for the polygon. Suppose this is a polygon P, Q, R, S, T. This is a polygon. This is A bar. This PQ bar is equal to A bar and this QR bar is equal to B bar. RS bar is equal to C bar and ST bar is equal to D bar. Then what is about the PT bar? Then what is about PT bar? This is a polygon law, which is very important law and very easy law. PQ bar is equal to A bar, QR bar is equal to B bar, RS bar is equal to C bar, ST bar is equal to D bar. Okay, then by triangle law, if we join this P and R, then by triangle law, in PQR triangle, A bar, this is A bar, this is B bar. So what is PR bar? It is A bar plus B bar. Now extend this. If we join P and S, this is A bar, this is B bar, this is C bar. So what is that? A bar plus B bar plus C bar. Then what is PT bar? This is A bar, B bar, C bar, D bar. So add all these, that is A bar plus B bar plus C bar plus D bar, which is equal to PT bar. This is very simple. Okay. So next point is properties. What is the properties? These properties are very important for JEE examination. These properties are very important for JEE examination. Sixth property, A bar plus B bar is equal to B bar plus A bar. This is commutative property. That means if we add A bar into B bar or if we add B bar into A bar, the value will not be changed. That is 1 plus 2 is equal to 2 plus 1. That means this is commutative. Then associative property. What is associative property? A bar plus B bar plus C bar is equal to A bar plus B bar plus C bar. Here change in by bracket. Here change only by the bracket. If we add first A bar plus B bar or if we add first B bar plus C bar, there is nothing to change. Value of LHS and RHS will be equal. Then identity, additive identity. If we add 0 vector in any vector, we will get that vector as it is. That is A bar plus 0 bar, which is equal to A bar. This is additive inverse. If we add that vector and its negative of vector, we will get 0 vector. Okay. Now, if there are two vectors A bar and B bar and there are two scalars M and N, then these properties. This is called as distributive property. If M plus N A bar, then M into A bar plus N into A bar. If M into A bar plus B bar, then which is equal to M A bar plus M B bar. And here M into N into A bar or Mn into A bar or N into M A bar, then all three values are equal. Now, this is triangle inequality. What is triangle inequality? This is magnitude of A bar plus B bar is less than or equal to magnitude of A bar plus magnitude of B bar. That means if there is a triangle, its vector along the one side is A bar, vector along the another side is B bar, then what is third side? It is A bar plus B bar. Then third side A bar plus B bar, its magnitude is always less than or equal to addition of other two. Magnitude of other two sides, that is A bar plus B bar. Okay. Any two vectors A bar and B bar determine a plane. Any two vectors A bar and B bar determine a plane. And vectors A bar plus B bar and A bar minus B bar. If there are A bar and B bar are any two vectors, then we make addition of these two and subtraction of these two vectors, then these two vectors also lies in same plane. Then next is examples. So what is first example? Find the unit vector in the direction of A bar is equal to 3i cap minus 2j cap minus k cap. A bar is equal to, given vector A bar is equal to, we write here. So what is unit vector along A bar? That is A cap. What is its formula? That vector divided by its magnitude. That means A bar upon magnitude of A bar. So what is A bar? A bar is this. So we write here this is as it is. What is magnitude of A bar? It is square root of its coefficient square and add it. That is 3 square plus minus 2 square plus minus 1 square. We will get root of 9 plus 4 plus 1, that is root 14. So this is the unit vector along that vector. Then next is, if A bar is equal to 3i cap minus j cap minus k cap and B bar is equal to minus 12i cap plus 4j cap plus 4k cap, then show that A bar and B bar are collinear vectors. In last note, we studied that what is, if A bar and B bar are two collinear vectors, then one vector is equal to scalar multiple of other, right? So A bar is equal to what is 3i cap minus j cap minus k cap. What is B bar? B bar is equal to minus 12i cap plus 4j cap plus 4k cap. If we get minus 4 common from this, If we get minus 4 common from this, then what is this bracket? This bracket is nothing but a bar. This is a bar. So it is minus 4a bar. That means b bar is equal to minus 4a bar. That is, one vector is scalar multiple of other. That means these two vectors are collinear vectors. Then next, the vector a bar is directed due north and its magnitude is 24. The vector b bar is directed due west and its magnitude is 7. Then find magnitude of a bar plus b bar. Suppose this is a point A or this is a vector. This vector directed to north. So this is in this direction, upward direction, directed to north. Suppose this is a bar. Now, then another vector directed to west. So here, directed to west. So on this direction, so this is b bar. If we join these 2 points, its terminal point and its initial point, if we join this, we will get a triangle. Okay, and which is a right angle triangle. Nothing but this is a right angle triangle. So what is AC bar? Then it is a bar plus b bar. So it is what? A bar plus b bar by triangle law. Then this angle is 90 degree. Then by Pythagoras theorem, what is that? Diagonal square is equal to one side square plus another side square. So this length means what? Its magnitude. Magnitude is the length. So magnitude of AC square is equal to magnitude of AB square plus magnitude of BC square. So magnitude of AB, what is this? Is a bar, that is which is equal to 24. So here 24 square plus magnitude of BC, what is that? B bar, which is equal to 7 square, which is equal to 625. That is AC bar is equal to what? 25. And AC bar, it is nothing but a bar plus b bar. So a bar plus b bar, magnitude of a bar plus b bar is 25. Then next example, in the triangle PQR, PQ bar is equal to 2a bar, QR bar is equal to 2b bar. Then the midpoint PR is M. If the midpoint of PR is M, then find the following vectors in terms of A bar and B bar. M is the midpoint of P bar. Suppose there is a PR is a line and M is its midpoint. So we have to find PR bar. Firstly, find PR bar. It is very simple example. PR bar means what? Here PQ bar. Given quantities, PQ bar is equal to 2A bar. QR bar is equal to 2B bar. PR bar is equal to PQ bar plus QR bar. So it is 2A bar plus 2B bar. This is very simple. Then what is next? Next, since M is the midpoint of P bar, so what is PM bar? PM bar is equal to half of PR bar, right? Because M is the midpoint of. So 1 by 2 PR, what is PR bar? That is 2A bar plus 2B bar. So which is equal to A bar plus B bar. Then next third is we have to find RM bar. RM bar also, this is M is the midpoint of PR bar. So RM bar is also half of PR bar, that is RP bar, which is equal to 1 by 2 RP bar. We will get here, so that is minus of 1 by 2. Why we get here minus sign? Because here is RP bar and we have to find, we have a value of PR bar. So we will get here minus sign. So minus 1 by 2 into this PR, that is 2A bar plus 2B bar, which is equal to minus of A bar minus of B bar. This is RM bar. But we have to find QM bar. So QM bar is equal to QR bar plus RM bar. So that is equal to QR bar is 2B bar, which is given in example, and RM bar we write calculate here, that is minus A bar minus B bar, which is equal to B bar minus A bar. This is our example. Then next example, here is A, B, C, D, E, F is a regular hexagon. Then show that AB bar plus AC bar plus AD bar plus AE bar plus AF bar is equal to 6 times of AO bar, where O is the center of the hexagon. Here O is the center of the hexagon. A, B, C, D, E, F. We join this. Okay. Then this is a regular hexagon. So AB is equal to ED and AF is equal to CD. Okay. This is a regular hexagon. So AB bar is equal to ED bar and AF bar is equal to CD bar. Then by triangle law of addition. What is that? AC bar. This is a AC bar plus AF bar. AC bar plus AF bar is equal to AC bar plus CD bar is equal to AC bar plus CD bar. What is that? In this triangle, suppose ACD is a triangle. ACD, this is a triangle. Here AC bar plus CD bar, which is equal to AD bar. But ACD bar is equal to AF bar. So we write here behalf of CD bar, that is AF bar. So that means AC bar plus AF bar is equal to what? AC bar plus CD bar is equal to AD bar. Then next, AE bar. Here, look at here. AE bar plus AB bar. Now, by this triangle, in this triangle, AED, in triangle AED, AE bar plus ED bar, here is AE bar plus ED bar is equal to what? AD bar. AE bar plus ED bar is equal to AD bar by triangle law. But ED bar is equal to AB bar. So we write by ED bar as a AB bar. So AE bar plus AB bar is equal to what? AD bar. So LHS, we write LHS is here. Now here AB bar, here AC bar, this AC bar and this AF bar, we calculate here AC bar and AF bar. What is that? AD bar. So we write here AD bar. Then next, here from this AE bar plus AB bar, here is AE bar and AB bar. AE and AB, that is equal to what? AD bar. So we write here AD bar. So there are 3 times of AD bar. This AB and this AE, this is AD. This AC and this AF, this is AD, and this AD as it is. So AD bar, AD bar, AD bar. These 3 are 3 times of AD bar. What is AD bar? This is the center of the hexagon O. AD bar is equal to 2 times of AO bar. So this is 2 times of AO bar, which is equal to 6 times of AO bar. So this is our example, that is according to regular hexagon. So in this lecture, we studied scalar multiplication of a vector, addition of a vector and its nodes, then subtraction of a vectors and some examples and its properties. You have to make a practice of this. So this is very important topic. You studied this in 11th standard. All these points are studied. You will study in 11th standard in physics topic. Thank you.